In this problem, we are asked to find how many milliliters of a 2.3 molar solution would be needed to add to completely react with the base, which is potassium hydroxide. Now, we're given volume and molarity, so we can use these to figure out the moles. But first, we need to write a balanced chemical equation. So we have potassium hydroxide. These charges cancel out, so those are good. With sulfuric acid, and we produce water and potassium sulfate. Now potassium sulfate has a -2 charge, and potassium has a +1 charge, so we need 2 potassium. Now we need to balance. So since we have 2 potassium on this side, we need to make this a 2 here. We have 2 oxygens and 4 oxygens, 4 oxygens and 1 make this a 2. And now we have a balanced chemical equation. Now we can use the volume and molarity. Using our formula, molarity is moles over volume, to figure out the number of moles of the sulfuric acid that we have. Sorry, potassium hydroxide. So we have 0.15 for the molarity, and the volume is in milliliters, so we need to convert it into liters in order to use it in this formula. And we would get 0.0195 moles of potassium hydroxide. Now that we know the number of moles of potassium hydroxide, we can use our balanced chemical equation to find out the number of moles of sulfuric acid. So for every 2 moles of potassium hydroxide, we have 1 mole of sulfuric acid. This gives us this many moles of sulfuric acid. Now that we have the number of moles, we can use that with our molarity to figure out the volume that we need. So again, molarity is number of moles over volume. So we need to solve this for volume. So we get that volume is number of moles over the molarity. This gives us number of moles, and our molarity is given to us, that's 2.3. So we get that our final volume is 0.0042 liters, because the volume in a molarity formula is always in liters, but they're asking for milliliters. So again, we convert 1, 2, 3, and we get 4.2 milliliters as our final answer of sulfuric acid.